Hello everyone. So in this tutorial I will explain how can we manage distributed transactions in Spring Boot. So the content I will explain one by one. So first is what is the problem with microservice transactions. In the next I will explain how to manage distributed microservice transaction. Next, the point is to the use cases for explain how we are managing in real scenarios. Then implementation approach, that what is the approach we have taken to implement this particular business scenarios. Then we can create those project in real time, means microservices, and then with that we can show the this how these transactions are managing or flowing with different microservices. So let's start with the what is the problem with the microservices transaction. So as we know, when we are going to write any kind of microservices, the any kind of microservices or anything, then obviously there are certain scenarios actually come managing the transactions. So problems like microservices comes with their own actually advantage and the disadvantage. One such disadvantage is managing the distributed transactions. Let's say our transactions having 4 different microservices as depicted in this picture, like order services, payment microservice, stock, and the delivery, right? So other microservice is responsible to managing the order related things, payment service is responsible for payment related things, stock microservice is related to the inventory kind of thing, stock managing, and delivery microservice is about to storing the address and other kind of details. And each microservice having different type of databases separately. And so let's say we are having different 4 transactions each for one. In how do you ensure that our transactions either commit successfully with all the 4 tasks succeeding or fail successfully if any of the tasks is not completed. The completed ones will be are rollback in case of failure scenarios. So in this scenario, if we are going to manage those kind of transactions, so Spring Boot actually provides the annotations called @transactional to manage transactions. But this works only within a single transaction, meaning if we are having some kind of monolith applications over there, we can use this kind of annotation so that we can manage the transaction in particular method. So now this is the actually problem statement. So what will be the solution for this one? So problem wise, if we go to the next slide, the solution of this one, so there is the one actually design pattern which solves the issue with distributed transaction in microservices, like this Saga pattern. Okay, this is actually uh, like uh, uh, it's it is the one of the way, or we can say it is the design pattern in which we can easily manage those kind of transaction. Let's say we are having 4 transactions as I was talking in the earlier. So for 4 tasks we need to create a compensating tax for each tax except the last one. For example, uh, as my last skin here, as you can see here, 4 ms. So we need to write 4 kind of compensating tax for each except the last one. Let me explain why. So if any tax is fail, then we can just run the compensating tax of the previous tax to roll back the original effect. So for example, if there are 4 tasks like T1, transaction 2, transaction 1, transaction 2, transaction 3, and transaction 4, then we are having 3 corresponding compensating tasks compensating tax 1, compensating tax 2, and then 3. If for example T1 transaction 1 and the transaction 2 succeeded but transaction 3 fails, then we need to run the compensating tax C2 and C1 to roll back the effect of transaction 1 and the transaction 2, means last in first out LIFO order. So the sequence of the transaction goes like like T1, then T2, then T3. If T3 has failed, then we are calling the C2, and then from the C2 it calling the C1. If we don't need a compensating task, then in the last task, because because if the last task fails, we just need to roll back the previous task. This is called the backward recovery mechanism. Now to implement this one, we are having this Saga pattern, and Saga pattern can be achieved using there are two ways actually, as we can I can explain over here, like choreography and the orchestration. So choreography means the tasks execute independently. Once one task is completed, it invokes the next task in the sequence. In case if the next task is fails, then it invokes the compensating task for the previous task. And the orchestration meaning the tasks are invoked by the another parent task. It plays the role of an orchestrator. It calls each task in sequence and based on their response decides whether to call the next task or compensating task. So this is a kind of like things. Next, if we go to the scenarios like business use case, if we are going to implement anything, so what is the scenarios? So let's consider one example like order management applications. So a customer can place an order and the order gets delivered to the customer, right? So this is the kind of the business use case. So how we can segregate this one? Let's say there are 4 microservices to take care of the flow: an order microservice which actually handles the customer order, a payment microservice which actually handles the payments for the order, and stock microservice which actually update the stock once order are placed, a delivery microservice which actually deals with the delivers of the order. Okay, so this is the like PT defined. So now the implementation approach, like what will be the approach we can take. So now like let's consider the like below function of the each microservice when a customer place an order. For example, order microservice having the create order, and payment microservice having the process payment, update stock like stock microservice having the update stock method, and the delivery microservice having the delivery order. When customer place an order, then those method will be actually called, and if like in case of the reverse we need to call, then here actually you have defining those things like reverse order for the order microservice, reverse payment for the payment microservice, and like reverse stock for the stock microservice, like something like this, as you can see over here. So this is a thing like updated one, updated flow of the order management microservices. So like order microservice having one: create order and the reverse order, create for the place order and reverse for the reversing the order, payment microservice for process payment and the reverse payment, same for the order as stock microservice, and the delivery, as you can see, delivery having only the one method like deliver order, and if it fails here, then it will automatically call this reverse stock. In the code, when I will write the code, then obviously I will show you in the detail. Okay, so if we are going to develop this one particular this 4 microservices, and then what kind of technologies I am gonna use. So I'm gonna use, for example, like Spring Boot 3, Java 17, Kafka for like event management, like as it is a independently microservices are going to run. So that's why we are going to use the Kafka. Like for example, if any customer want to place an order, then it will call the orders API, it will place the order, and it will actually push the data into the Kafka, and from the Kafka actually read data from the other microservices like uh, payment, then payment to stock, then from stock to like delivery. So those kind of things will be managed by the, means we are pushing data into the Kafka. As a dependency management tool, we are using the Maven here. And one more thing, as a database, we are using the I will use the in-memory tool, in-memory database like H2. So this is the briefly explaining of this kind of how we are going to implement this one, and what are the basic structure of this overall thing, so that it will be easy to understand how you're going to take. So next, what I will do, I will like uh, create the project for each microservices, and accordingly I will also explain how we can create those things, and I can write the code so that we can easily understand. Let's create those project. Okay, so for creating those MS actually microservices, I have already created the structure for all four microservice like order, payment, stock, and the delivery. So the project can be created from the like Spring is initializer. You can easily create those project. Just you need to select like few things from there, dependency tool, the Java version, and like what kind of dependencies you need. So for me, I have used like dependency wise, like as you can see, the Spring Boot version 3.1.1, and then like Java 17, Starter Data JPA, Starter Web, Lombok, H2 databases, and like Kafka, as we are going to use this Kafka. So Kafka is there. So these are the dependencies tool that I have used. So now like list for order actually what we need to do, we need to like it will place some order. So for that like and then we need to store this data into the databases, and we also need to push this data into the Kafka. In case of failed, we need to update this data into the Kafka, into the table. So that means we need to create one controller, and then like we need to create service and also the Kafka listener and the Kafka pushing kind of thing. And in case of the reverse, like is in there any case of failure, then it will some call will come from the like payment services, so that it will revert. So that actually for that also we need to write some kind of services. So let's first create one package for controller. So the name should be like you can say order controller, new class order controller. Next, so we should like annotate it with REST controller, and also like we can provide some kind of request mapping just to giving our customized path over here slash API for example. Next we need to create like the method public void, for example it's a create order. It will take some kind of, obviously it's like post mapping. Here also you can put some kind of like path, for example orders, and here we need to provide some kind of request body, like for example customer orders. So we need to create this DTO. Let's create maybe we can create another package, like instead of controller it should be like DTO, and here we can create new class like customer uh, order. Okay, and it will take in like it will take some inputs, for example like private string, then item, next private int quantity, next private amount actually, so it's a double, private string payment method, next like the order ID. It will actually not come from here, but we can set from the program. Then like we can provide the address, and extra what we need to do, we need to provide some kind of getter setter, and then like setter. So this detail is done here, and next like we need to, okay, here actually we need to create actually entities. So let's create another entity, for example order. it's also having similar kind of like fields, so I'm copying from over here. Just I will remove or update something if needed. For example, like uh, it's we need to add one ID, auto generated ID actually, private long ID, and here it should be annotated with @ID, so that it will be Jakarta, and then it will be generated value, and obviously we can like annotate with column, so that it will be mapped with the database field. And here actually items, quantity, amount, and then another field we need to keep over here like status, just to maintain like what will be the status, success or failed, those kind of, for those scenarios. And also we need to annotate it with like getter, and then setter, and also like we need to annotate it with entity, else it will be treated as a like table, hibernate table. So all this is done. Another detail we need to create for like managing the event, like we need to send some data into the Kafka. So for that also like we need to create some event. So for example, order event, and here what we need to like keep two field. One is the like customer order, it will contains all the detail, and next like what kind of type it is, what kind of type, string type, and here we need to like provide getter and setter. Okay, so this is pretty about this. Let's write the code for this controller. So here what we can see, we need to like save data into the database. So for that we need to set the data into the like entity is equal to new order, and then we need to set different type of data like amount can be come from here dot get amount, next order dot set item also like come from our input get item, next set quantity, it is also coming from get quantity request, and next like status, set status, and like initially it will be as a created, right? Next what we need, okay, we need to create actually another repository, so it will be one interface, so that we can save the data. So order repository, and it will be like extends CRUD repository, and here it will be like string, sorry, it will be order as the entity we need to mention over here, and here it will be long as the ID is the long. So this is done. Now here actually what we need to do, we need to annotate auto private order repository, and then we can use one kind of try catch, and here we need to using this repository dot save an entity means order. So that means we are saving the order here. If and after, if this order is successful, means if the repository.save is successed, then what we can do, we can just set the order ID. Accordingly it will be needed. So how we can get this one? We need to actually, as you know, like this saved actually return the entity, right? So we can assign with this one, and from here we can get the order ID, and that particular order ID we can set get ID, that we need to set over here. And here actually we need to set order event, so that we need to push the data. And then set order, customer order, and then we need to set the type, order event dot set type. And the type should be what kind of type? Like it's a kind of order created, right? So we need to pass this as a created. And once this is done, then we need to also pass this one into the Kafka. So Kafka will push this data into the Kafka. So for that we need to use the Kafka template. So for about this Kafka template topic, what I have already want a session video for this one, so I will share the link in the description sections, how we can, like, you can use those Kafka installation, like how you are going to install this Kafka into your system, how you are going to run. So those kind of already I have one videos. I will share those link into the description section. Please follow this one. I am just using the Kafka template, and here what we need to do, we need to like provide order event as we are sending the same details. So it's a Kafka template, and with that Kafka template dot send. So send here actually what we need to do, we need to like give the topic name and this particular order event. And here we need to provide the topic name. Topic name you can give anything, like I can giving one like new order, for example, as it is a new order. In case of it is exception, if it is showing the exception, then what we need to do, we need to like set the status as failed and update the data into the database. Then we need to save the data. Okay, so controller perspective, this is done. Next, what we need to do, one more thing over here in this MS, we need to create another service class actually, which will actually like responsible to reverse the order detail in case of like any failure scenarios. So for that we need to create one service. So for example, we can say it's a reverse order class, reverse order, and we can annotate it with @component as it is service class. Next we can write method, as the data will be like listen from the Kafka listener, so it will be a Kafka listener, we can say. So we need to write one method over here, reverse order, and here actually we can will receive the event, and what we can do, we can print like the reverse order event plus event. As I'm not using the logger one, so that's why I'm using the sysout just to demo purpose. You guys can use anything. Here what we need to do, we can use here also, we can write the catch, and inside of the try we need to like read the data, means we can actually as event is a JSON format, so we need to convert it to the actual DTO. So the DTO would be order event is equal to new object mapper. Actually we can use the object mapper, then read value. So from where we can read event, like this is the event, and what will be the like output, it will be order event dot class. So it will convert this the event actually to the order event class. Next what we need to do, we need to find this particular order from the repository. So for this one we need to auto add this order repository, and based on this repository what we need to do, we need to like find by id dot find by id. Here we need to pass id. So how to get this one id, like order event here from get customer order, and here we can get the order id, right? So this is the id actually. So it will return us the optional of order, optional of order. Next what we need to do, we need to check like this particular order, if present, then we need to do kind of operations like check the status is failed, because it's a like reverting of this particular order. So we are updating this status as failed. And what do we need to do over here, we also need to do something update this data into okay, so some kind of syntax error. Okay, here actually we need to open this one, closing this one, as it is a multiple statement we are going to write inside of this one, so that's why. So here actually you are updating the status, and then repository order repository dot save order. Okay, so this is a kind of the reverse order, so that's why we are updating this status and save the data also. And here just we can like seize out exception. In case of any exception, then like we can write exception occurred while reverting order details. Okay, so this is done, and next like what we need to do, except this one, we need to annotate with the Kafka listener, right? Kafka listener, and it's taking some kind of parameter like topic name. What is the topic? So topic is reverse orders, and also we need to maintain some kind of group ID. So group ID is like orders group. Okay, So that means when any kind of reverse order is happening or necessary, then from payments actually it will push data into this topic, and it will listen by this Kafka listener, and after listening it will actually parsing the data from JSON to DTO, and here we will find based on this ID if it is present into the database, then it will mark this as a failed and save the data. So this is pretty much logic of this order microservices, and we are going to write the same logic for the payment. Let's write the code for the payment also, payment microservice. Let's create the payments MS microservice. As we are creating the order microservices, so the payments MS should be similar kind of coding we need to do for this one also. What actually it do? So from the, as we discussed in the order MS, we have write some code like in the controller. If the order is successfully done, then we are pushing this particular event into this Kafka template, using this Kafka template, right? In the new order topic we are pushing. So in the payment MS, what we will do, we will take this actually event from this template, like as from the new order topic, and then accordingly what we need to do, we can process the payment, like update the payment details and all the other things. So let's create the payment controller first. So let's create another package. And one more point, actually here in the resource file, like application.properties, you can get those things like the data source URL like payments DB, and the Kafka server URL, and the group ID of this consumer, and also the serializer and the deserializer. Regarding the Kafka tutorial, I have already attached the link for this Kafka kind of thing, so that you guys can understand. If you don't have any idea about this one Kafka, like how it is working, so you guys can look into the video. And one more point, so as I'm going to use these 4 microservices like order, payment, stock, and the delivery, and at a time we need to run all the program, right? So all the MS actually, so we need to start those particular microservice in unique port. So as I'm not mentioning any port for this order microservice, so it will be default start with this 8081, and payment microservice it will be start 8081, like stock it will be start in the 8082, and the delivery will be start with 8083. So in that fashion I have provided those ports, so that at a time all the microservice will run. Let's create another package over here, so that we can create dot controller, create one class, new class, we can say like payment controller. Okay, and we can annotate it with @controller, as we don't need to write any kind of REST services, so that's why. Now we need to create one method, actually one listener method, which actually listen from the topic, right? So here we can say like it's a process payment, and what we will get like event, and this particular method actually annotated with Kafka listener. Kafka listener, and here we need to provide the topic, like from which topic actually the data can be read. So the topic would be whatever the topic we mentioned in the order details, so it will be orders. And here also we need to provide the group ID, and group ID should be like orders group. Group. Now let's write the code for this one. And for logging kind of thing, I'm not using any kind of logger, like say log4j kind of thing. So just putting the sys out, like payment, process payment, event event. Okay, next, like we need to like wrapping this particular order event, like as we are sending the order event in the listener from the order also. So here we will also get the same DTO. We need to just like map these things. Order event is not here, so we need to create this particular DTO. Package, create the new creating the new package for DTO only. Like here we can create another class, like customer order. Customer order also we need to create, and then the like, or else what you can do, we are having all the things in order. So let's copy from over here. Yes, order event is here, and this customer order is also required, and this repository is also required. I will just rename it, right? So copy from here, and I am pasting it over here. Yes. Okay, so for this actually uh, what here actually we also create one entity, so that will be kind of like for storing the data into the payment table. So for that we need to create one entity over here, right? So let's create another package. Instead of DTO it will be entity, and the entity name should be like kind of payment. Okay, and here we will need to create some kind of field. So private, first one is long, as it is ID database, so it will be treated as a ID, and also it will be generated value, auto generated value. Next, like payment mode, what kind of payment mode it is. Next, like we can put kind of the order ID. Next, like amount, and next, like what we can create next, like the status, like what will be the status, a success or failed, right? So that also we need to keep over here. And next we need to like annotate all this field with column, so that it will be mapped with any means database fields. And also we need to like annotate this class with entity and getter setter. So means this entity is now ready now. Yes. Okay, next, once the entity is ready, then also we will rename this repository, so that it will be, we can keep it here. Okay, let's rename it. It will be kind of payment repository, and here instead of order it will be payment, right? We need to pass the entities, so it will be payment. So this is also done. And like also like it will be what it will do from the payment controller. Once it will get the data, then it will update the means insert the data into the database with success, and also it will create another event let's say payment event, and then it will push data into the Kafka. So for that we need to create the payment event. So instead of the order event, we can rename it with payment event, and then for structure of this payment event would be similar of the order event, the what would be the type and the order. So here is a nothing change. Let's go over here. So here what we will do, we will pick this particular actually event, let's say order event. Okay, we need to create another event similar to the payment event. Let's create it, and renamed it with order event. Yes, let's order event equal to, so how we will map means string to this actual DTO. So here is the things, like you can use the object mapper. Using the object mapper we can do the same thing, like object mapper, and then what we need to do, we need to read the value, right? Read value, and here we need to pass the string, and then what kind of class name, actually order event dot class. So that means mapping is done actually. What it is showing, okay, it will throw some exceptions, so we can throw this one, or maybe instead of this multiple, we can just create only exception instead of the multiple. Okay, so means data is ready, and next what we can do, we can create another payment actually entity. We need to set the data over here, new payment, and here we can set the data, payment dot set amount, payment dot set mode, payment dot set order ID. As we are having the order ID, so we can put it over here. We can get from the request payment dot set status. So status would be success. If it is failed, in case of, then we can treat it as a failed. So from where we can get these things, from order event we will get the data, right? So this dot get order, so it will be like customer order. So here we can get those things. Now from this order dot get amount, what would be the mode? We can fetch these things also, payment mode, and the order ID, order dot get order ID. So that means we have set the data into the payment table. Now we need to save this data into the table. So what we need to do, we need to annotate with, so we can do the same thing with repository. Okay, now what we need to do, we need to save the data into the payment data table actually. So for that, for saving the data into the database, what we need to need some kind of repository. So that repository already created, right? That payment repository. So we need to use this one, payment repository, and for example it's a repository, and now we need to save this one. Okay, do one more thing, save those things inside of a try catch. In case of any exceptions, while saving the data, then we can revert those things, or maybe we can, what we can do, we can update those things, right? So like a repository dot save, and we need to pass the entity payment. And once this is done successfully, next what we need to do, we need to, like, if this is a successful, then we need to pass this event to the stock so that stock can be updated, right? Means order is placed, and from the order the request is coming to the payment, and if payment is success, then we'll send the request to the stock so that the stock can be updated. Like suppose we are, if we are purchasing some 10 books or 10 some any quantity, that quantity should be updated. So this payment event, we need to set data over here, payment event, and we need to event dot set order, it will be order, and next, like we can set type, and the type would be like what you can say, it can be payment created, it's a payment created, payment created. Okay, duplicate local variable. Okay, it's saying, so we need to rename it with like payment event, and here we need to set the order, and then we need to set the type payment created, and then what we need to do, we need to send this particular event to the Kafka. So for that, what we need to do, we need to auto-aware Kafka template, because without this is not possible. So Kafka template, and here it will be, the type would be like string, as we are passing as a string, and then here it will be a order event. Sorry, it will be a payment event, payment Kafka template. Payment Kafka template dot send, and we need to pass like topic name, like in which topic we need to send this one. So for this, the topic name would be new payments, and here we need to pass this DTO. Okay, now in case of any exception while saving this data, right, then what we will do, in this case of, in this scenario, we will update the payment status like failed, and also we need to call the reverse order, means we need to send one notification to the Kafka that order should be reversed. So let's create this one, like payment dot set order ID. We need to use this one, use this two, and it will be failed, and then we need to save this data dot save payment. Next, like and for reverting the order, we need to create the order event, right? Okay, order event is already there. So order event, new order event. Okay, here actually we need to set the order and the type. So the order would be let's copy it and put it in this order, and here it will be order reversed. And here also we need to use the Kafka template. So as this is for the payment one, so we need to create the another template for reverting the order. Kafka template string and then order event. Order Kafka template, and this part using this template we can call this order template and send. Here we need to send the topic, and the topic name would be the reverse order. Orders and here OI. Okay. So this is the like overall thing. So like what it will do, it will listen the data from this topic new orders, and it will once received, then it will like map the read value from this event, and then based on this we are means preparing the payment table data from this event, and accordingly we are setting the status as success, then we are save the data into the table. If is there any issues like any exception, then it will from the exception it will update the payment status as failed, and also like send the reverse order request so that it the reverse the request. So this is the about all these things over here for the payment. Now the similar fashion is required for the stock and the delivery. Let's create the other microservices. Forgot to mention one point, like from the payment MS actually we are sending the data into the Kafka for that stock, for updating the stock. Now if any times if any failed is occur from the stock MS, from the stock actually it will call the payments for reverse the payment, and from the payment actually it's call the order, reverse the order. So that reverse mechanism also I need to mention. So for that what I did actually, I have created another service class which is actually doing the same thing. So something like this one as we are doing for the order one. So this reverse payment actually doing the same thing. So it will listen from this topic reverse payment and payment groups, and here actually it is reading the data from this event, and here actually it is finding data using this order ID. So like if it is a if it is a success, like if it is get the data, then it will actually update the status with failed, right, and it will save the data over here. And from here also what we will do, we will also like call the order event so that order actually revert, right, so that the order is not successfully placed. So this is the like revert mechanism. So this is actually I forgot to mention there, so that's I explained. Next, like I have created the similar kind of another two project. The logic wise and the architecture is also same, like for the stock and like for the delivery MS. So let's check this one, stock MS. So this for this MS we have followed the same pattern, like there is one controller and then D2 and entity and service. So from the payment it will come the data inside of this update inventory for this order, and then like here actually it is same doing the same thing, like it is reading the data from here using the object upper. Instead of these two we can just like throw exception, that's fine, no issues. And then what actually we are doing, we have created the like repository, and from this repository we are actually in this repo, as you can see, like we have write another customize actually method find by item. So this based on the item it will actually fetch the data. It will be multiple data can be possible, and based on that if it is not exist, then we can say definitely that stock is not exist. Then from here we are throwing the exception. If the you are throwing the exception, then it will go over here, and from here you will reverse the payment if the stock is not exist. Now, like you can check if it is success, then we are just like updating this quantity. If it is available, then we are just updating this as over here, like minus this one quantity, we are just overriding one. And also we are marked as a stock update, and then we are like sending the data over here. And as you can see here, we are just saving the data into the database. And so once this is successfully done, then with this event we are setting the data and order also, and then we are sending the data into the new stock, like into the delivery system microservice. From that it will listen the data from this topic. In case of the exception, then we are reverting the order. And here also we have created like another actually REST APIs. So reason of this, like initially we don't have any kind of stock, right? So for adding the stock, we need to call this one. So what it will do, it will actually add the items in the like particular this stock table, right? So this is about this stock repository. Let's take another example for like delivery microservices. So as you like stock microservice is just responsible to the adding the items into the stock and also like update the stock details. So those kind of responsibilities for the stock. Here like similar fashion, similar manner. So here in this controller, we are listening the data from this new stock, and here it will actually same fashion like event, we are wrapping this data into this delivery event, and from here we are getting the order details. If the address is null, then we'll throw the address not found exception or not present exception, and then accordingly we'll if it is not, then we will update this like case in this scenario actually, if it is throwing the exception or maybe if the address is not available, then actually it will come over here and we will mark this status as failed, and we are saving the data. And also from over here we will actually send the reverse stock means actually it will call the reverse stock topic, and from there it will push data, and from over here it will come this here. Let's take this service example. Yes, reverse stock. So it will listen from here and it will update this, and also it accordingly it will update the data. Like previously, suppose 5 quantities and in the reverse quantity is the 10, then 5, it will update the 5 plus 10 is will 15, and accordingly it will also update the like call the payment reverse topic, reverse payment. Then accordingly it will goes to the payment ms payment microservice. Here is a reverse payment topic here, then from here actually it will listen the data. So this is a similar fashion. So now come to the over here, if it is a success, like if the address is available, then it will update the address into this segment table, and accordingly table name should be this one, delivery. Okay, and accordingly it will save the data. And if it is success, then from here we don't need to call any other topic as it is the last microservices, so that's why. So the overall flow, this is kind of thing like how we are managing the transactions and like how it is flow. Let's check the databases. So I will open the consoles. Okay, so like if you want to run all the microservices, so the prerequisite is to, we also need to start the Kafka. So let's like start the Kafka. So for me Kafka is inside over here, so we need to run cmd, and we are having means first before running the Kafka we need to run the zookeeper. So this is the like kind of syntax for running the zookeeper. So let's start this zookeeper. Once it will run, then we will start the Kafka server. It will start. Next we can again like run the Kafka now. It will run the Kafka. So once this will done, then we will start the all the microservices. This started. Okay, now let's start one by one. Run as Spring Boot app. The H2 console. Order table, it's saying something begin not null. Okay, okay, let's connect. Okay, it would be orders db. Okay, so order is not created. So okay, it's actually internally it's some problem with this order table, because internally they are trying to same syntax, so that's why I need to like renamed it, else it will not work. So let's rename to it, for example, order table. Now let's start. Mm, okay, it should work now. Let's see. Yeah, it started. Yes, it started now, and also Kafka is also like started, right? So these are started, means order image is started. We can also check the like H2 console. It will also like created orders db. Yeah, orders table is created. Next, we need to run the other image also, like the payment. Let's see if we are getting any kind of issues or not for this payment. Yeah, it is also started. And next, like it will start in the 8081. So let's it's not orders, it's a payments db. Okay, and the payments is also created, right? Next, we need to create the like start the stock image. It will also start. Okay, yeah, it started, and it will be started 8082, so we can get the is to control the 8282, and the db name is should be stock db. Yeah, warehouse is also created, and the last one is the like delivery microservices. So delivery microservices should also start. Once it will start, then we will do one transactions. First we will add the items, and then accordingly like we can okay, it's also started, and here 8083 delivery. Yes, yeah, the delivery also created. Let's try with, I have created one like request for the orders. Let's create this one. So the order is success, right? Let's see, like select star from order table. Execute this one. Books is created, right? Let's start from payment. It's throw some order ID. Okay. In which MS payment MS it's failing. Okay, send back to this. Okay. Actually field names should similar, else it will throw some exception. Let's see like what happened here. The partitions this item, quantity, amount, payment method, order ID. Okay, this one. This is the typo. So we need to fix for this payment. Customer order and order event. Okay, it is coming from the order. So let's check like order. Yes, here. This is the typo mistake. Okay, we need to fix over here also. Shortcut key actually message are not working, so that's why I do it manually. Okay. So what I need to do, I need to stop the order MS and then again we need to rerun. Order MS we need to stop. Payment stock, need to clean the log and then delivery, and order MS is off. So let's rerun the order microservice. We need to rerun it. It's started now. Let's try again. Okay, payment mode also it was not taking. Let's check like if any kind of any type over there. Payment method. Let's try to run this one. We are getting success. Again we are getting some kind of issues in the stock. So okay, payment method I was checking, like I need to check this one also. Let's check why it is throwing this exception in the listener. Okay, so we need to go in the stock MS. Here we need to check like the delivery event, payment event, customer order, payment mode actually. Okay, it's a payment mode, so that's why it's not coming. Okay, we can do one thing. What we can do, we can update can do the payment mode instead of method. And here also payment mode. Okay, and next in order MS, so we need to stop the order MS, means we need to rerun it. Order MS, and same also I need to check for the like payment MS also, like if I have used the same thing or not. Yes, it also is change. Okay, in controller let's see like okay, payment method, instead of this it will be payment mode. So we need to like also stop the payment application. Stock is fine. Okay, now let's start the order one. Is started. Next we need to again to restart the payment microservice. Okay, it's also started. Clean the log. Okay, now again like retry this one. Okay, it started now. All should success. Okay, okay, let's go to the tables. So like from the order table we can, let's see like what is the status. Okay, it's restarted, so we need to re-log in again. Orders db, yes, and select star from order table. Yeah, it's a failed. Let's see what is the reason for it. Payments db, let's check the payments db. Payment, it's also failed. Next we can check from the warehouse. Okay, so here is a like no quantity. So why it is failed? Because of like we don't have any kind of, so as we don't have any kind of quantity, so that's why it's failed. So we can also like check the like not delivery one. If we go to the stock, it's a order ms, it's a payment, it's a stock. So here you can see like it will throw some kind of exception. Okay, stock not exists, so reverting the order, right? So that means stock is not available. So what we need to do, we need to add some kind of stock. So this one, so for example books and 100, so then we will get the to means it's a success. Let's see the stock database. Select star from delivery. Why it is not stored? Let me check. Okay, 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 I was checking in the wrong place. It will be, I need to check in the warehouse, so it should be data added. Yeah, 100 books, right? Now let's try with try to purchase something with the 10 items. Okay, it's success. Now let's see like order, yeah, it's created, and also the payment, it's success. From the warehouse means we have purchased 10 quantity, so it should be 90 now. Yeah, 90, and from here it will also placed one, yeah, Bombay. So in that way like you can see like if somewhere it's failed, maybe if we are passing not passing the address, then it will be failed. If we are something means anywhere, if it is failed, it will revert all the transaction with failed, as we are means seen in the earlier stock. When the stock was not available, on the same time the first is failed, right? And it also revert this payment as well as the like order. So in this way like we can maintain the order of the distributed microservice transactions. So this example, what we did, if we want to summarize, we have created the 4 microservices like order and payment, stock and delivery. This four microservices having the each services class, which having the some own functionalities: order placed, then payment procedure, then stock management, and then the final delivery. If in between anywhere is failed, then from there it will revert all the transactions. So either all the transaction will be success or all the transaction will be like failed. So in there any case, anything, any comment, so please do let me know in the comment section so that I can answer those things. And don't forget to subscribe my channel. Thank you.